Ever found yourself gazing out of an airplane window and pondered why they are round instead of square? A simple question, but the answer is far from it. Welcome to the fascinating world of aviation design, where every detail, no matter how small, has a purpose. Today, we're diving into the enigma of round airplane windows. It's not just a design preference or an aesthetic choice. In fact, there's a deep scientific and engineering rationale behind this seemingly simple design element. Airplanes are a marvel of modern engineering, and every part of them, from the wings to the windows, is carefully designed for maximum efficiency and safety. This includes the shape of the windows. Now you might be wondering, what could possibly be so important about the shape of a window? Well, the answer lies in the realm of physics and engineering, and it's quite intriguing. Perhaps you've noticed that not all windows are round. The windows in your house are probably square or rectangular, right? So why not use the same shape in airplanes? It would certainly make things easier and more uniform. But when it comes to aviation, easy and uniform don't always mean best or safest. The round design of airplane windows is not just a stylistic choice, it's a matter of life and death. Sounds dramatic, doesn't it? But it's true. The round shape plays a crucial role in ensuring the safety of everyone aboard. Intrigued yet? Well, you should be. We're just scratching the surface here, folks. Behind the round airplane windows lies a tale of scientific discovery, engineering brilliance, and, believe it or not, a few catastrophic failures. It's a story that's as much about the evolution of aviation safety as it is about the shape of a window. Buckle up, folks, as we are going to take a deep dive into the world of aviation design and unravel the mystery of round airplane windows. To understand why airplane windows are round, we need to take a trip back in time. In the early days of aviation, airplanes were designed with square windows, mirroring the designs of homes and automobiles. This seemed like a logical choice. After all, square windows had worked well in other contexts, so why not in airplanes? The initial days of commercial aviation were filled with a spirit of innovation and exploration, but also with a fair share of learning through trial and error. And one of those lessons came from an unexpected source: the windows. In the 1950s, the world of aviation saw a revolutionary leap with the introduction of the world's first commercial jet airliner, the de Havilland Comet. This sleek, shiny marvel of modern engineering was the envy of the skies, boasting speeds and altitudes that left propeller-driven airplanes in the dust. The Comet was a symbol of progress, a beacon of the future, and it had square windows. However, the Comet's reign was short-lived. Within the first year of commercial flights, Comets began experiencing catastrophic failures mid-air. Investigations into these tragic incidents revealed a chilling fact. The square windows were causing the airplane's fuselage or body to crack. It was a shocking revelation, an unforeseen consequence of a seemingly innocuous design choice. The sharp corners of the square windows were acting as stress concentrators, causing the metal around the windows to fatigue and eventually crack under the intense pressure changes experienced during flight. The aviation industry was stunned. Square windows, the standard in every other form of transportation, were proving to be a fatal flaw in airplanes. This prompted a swift and significant change in airplane design. Engineers began to rethink the window design, looking for a solution that would ensure the safety of the passengers and the integrity of the aircraft. So, it turned out that square windows were not the best idea, but why? Stay tuned to find out. Ready to have your mind blown? Let's delve into the science behind round airplane windows. To understand why airplane windows are round, we need to discuss a fascinating concept known as stress concentration. This is a principle in physics and engineering that explains how stress, or force, is distributed within a material. In the case of an airplane, the cabin is pressurized, meaning there's a high force inside pushing outwards and a low force outside pushing inwards. This creates stress on the airplane's structure, including the windows. Now, imagine you have a piece of paper and you're trying to tear it. It's quite difficult, right? But if you make a small cut on the edge, it becomes much easier to rip. That cut acts as a stress concentrator, focusing the force you apply in one area, making the paper weaker and easier to tear. Similarly, in the early days of aviation, square or rectangular windows were used in airplane cabins. These windows, however, had corners, and these corners acted like those cuts in the paper, concentrating the stress from the pressurized cabin. Over time, this led to cracks forming, and in some unfortunate instances, catastrophic failures. This is where round windows come to the rescue. The beauty of round windows is that they don't have corners. Instead, The stress from the pressurized cabin is distributed evenly all around the window. This means there are no points of concentrated stress, so the structure is less likely to fail. So the shift from square to round windows wasn't just for aesthetic reasons, but rather a crucial move to ensure the safety of passengers and crew. It's a brilliant example of how understanding the basic principles of science and physics can lead to life-saving engineering solutions. So, now you know why square windows were a no-go, but there's more to it. Now, let's look at the double-pane design of airplane windows. Ever notice that airplane windows consist of 2 layers of glass? That's not just for show, folks. This design is a clever engineering solution to 2 problems: insulation and condensation. Firstly, insulation. The double-pane design creates an insulating barrier between the cold outside air and the warm cabin air. This helps maintain a comfortable temperature inside the plane, even when it's freezing outside. And we all know how important that is when you're cruising at 30,000 feet. Secondly, condensation. The gap between the 2 panes allows moisture to escape, preventing condensation from forming on the window. This not only provides clear views for passengers, but also preserves the window's integrity by preventing moisture damage. So, the next time you're on a plane, take a moment to appreciate the round windows. They're not just there to give you a great view of the clouds or the city below. They're a testament to the genius of engineering, working silently to keep you safe and comfortable throughout your journey. Intriguing, isn't it? But we are not done yet. So, we've explored the why, but what about the aftermath of this design change? In the grand scheme of aviation history, the shift to round windows has been nothing short of a game changer. It's like the Beatles of airplane design, revolutionizing the way we see things, literally and figuratively. Let's consider safety. Before the advent of round windows, planes were more prone to structural failures due to the stress concentration at the corners of square windows. But with the introduction of round windows, the stress evenly distributes around the edges, making the plane safer for us, the passengers. It's like having a guardian angel in the form of a round window, watching over us as we cruise at 35,000 feet. But the evolution didn't stop there. Modern innovations have taken airplane window design to new heights. We now have smart windows that allow passengers to adjust the amount of sunlight entering the cabin. Imagine that, being able to dim the sunlight with just a touch, like some sort of aviation wizard. And then there's the Boeing 787 Dreamliner, a true marvel of modern engineering. It has larger windows to provide passengers with a better view of the skies. Because who doesn't love a good cloud show, right? But hold on to your seats, because the future of airplane windows might be even more exciting. Engineers are exploring the possibility of panoramic windows, offering an immersive viewing experience. Imagine flying through the northern lights in a plane with panoramic windows. It would be like being in a sci-fi movie, minus the alien invasion. So there you have it, folks. The next time you glance out of an airplane window, you'll appreciate not just the view, but the brilliant science and engineering behind it too. Airplanes don't have square windows for a reason, and that reason has shaped the safety and experience of air travel in ways we often take for granted. But now, you're in the know. And who knows? Maybe you'll be the life of the party at your next trivia night.